In the last video, we talked about how to find the derivative of a function graphically. And we did that by drawing tangent lines to different x values on the function, and then finding the slopes of those tangent lines. And then using the slopes, we graphed the values of the slopes down on another graph, which was the graph that represented the derivative. Because the derivative is the graph of instantaneous slopes of the original graph. So here is practice problem number 6 from lesson 1. I drew tangent lines on this graph and then graphed the slopes at different instances on this graph, and then drew a best fit line between them. And this method is rather slow and inaccurate. Each person who draws a tangent line will have a different slope on their tangent line, so their graph will not be perfect. That's like really in calculus, we're not going to be drawing tangent lines with every function we have. We're going to find derivatives analytically, which means using numbers, not just graphs. Using equations and numbers. And to do that, I need to introduce something called limits. And limits you may have heard before. I'm going to give you a real brief overview here, but in an actual calculus class you could spend up to a month talking about limits before you actually get to the definition of the derivative. But we'll get to that today, definition of the derivative analytically, which is exciting. So a limit on a function is the value that the function approaches. So if I asked you to find the limit as x approaches 5 on a function, which would look like this. This is the notation for it. The limit, which we just write lim, as x approaches a value, here I put c, on a function. So limit as x approaches c of f of x, then it'd be a number answer. It's going to be like a point, a y value of a point on the graph. So here's an example of it. Limit as x approaches 2 of 2x, so the function is 2x. You can imagine the graph of 2x, and the value that it approaches as it goes to 2. I'm not going to explain how I got the answer yet. I'll talk about that later. And I could also say the limit as x approaches 3 of f of x, and then give you f of x beforehand. So then you just have to basically substitute. You could do it in your head. Substitute limit x as x approaches 3 of x squared equals what? So this is the notation for it. Get used to it. Lim as x approaches that, and then f of x next to it. Okay, so you take up 2 lines with the limit as x approaches the value. So before doing the limits like analytically with numbers, we're just going to do them graphically. These should be pretty easy. All we have to do is look at the value that the function approaches, the y value that the function approaches as I approach an x value. So these aren't even, or this one, I didn't even tell you what the function is. Like I didn't tell you what the equation for this parabola is. I just drew it and I give you 1 point. That's when x equals 5, y equals 12. So what is a limit as x approaches 5? Well, if we approach it, which means from farther away, going to closer and closer and closer and closer and closer and closer and closer, not necessarily touching it, but seeing what the y value approaches as we get close to 5. Well, it approaches its actual value. It approaches 12, right? As I get closer and closer to 5, the graph gets closer and closer to 12. But for a limit to work, it has to work from both directions. So we just came from the left side here, like on this side of the point. It also has to work on this side of the point. So as I go from like 6 to 5.5 to 5.1 to 5.01, I see that the y value approaches 12. So that means the limit as x approaches 5 of this function, don't even have the equation for it, we just have the graph, is 12. So your answer will be the y value, right, for the y value for this x value. Okay, let's do this one. This time we were given a function f of x equals 2x plus 2, and graphed there. And there's a hole here, and a hole is just a point that's missing in this graph. don't worry about too much about it. We're not really going to have to like use them at all. It just means this is a graph of 2x plus 2, but there's like no value at x equals 2. But that's okay, because with limits, we don't actually care what the value is. We only care what it approaches. So if we approach x equals 2 from the left, or from the left, it's going to approach this value of f of 2. And we can find f of 2. We have the equation for f of x, so f of 2 would be 2 times 2 plus 2, which is 4 plus 2, which is 6. So that means we know f of 2 equals 6 here. And then from the right direction, from the positive direction, it also approaches, gets closer and closer to 6. So that means the limit as x approaches 2 of this function, 2x plus 2, equals 6. Okay, how about this one? This, I said g of x is cosine x, equals cosine x. And if you don't know trig, don't worry about it yet. All you need to know is that the value of cosine x at x equals 0 is 1. So the limit as x approaches 0 from the negative direction, as it gets closer, as x gets closer and closer to 0, y gets closer and closer to 1. And then as I approach from the positive direction, same thing. As I get closer and closer and closer to 0, y approaches 1. So that means since it approaches 1 from both directions, I can say the limit as x approaches 0 of cosine x equals 1. All right, and our last example is this graph, which is y equals 1 over x. And in this graph, there's actually an asymptote at x equals 0. X equals 0. So we're asked for the limit as x approaches 0. If we do our process of looking from the negative direction, as it approaches 0, it's going to go down, 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 off the screen, down to negative infinity. So it's an asymptote, so it's never actually going to touch that. It's going to go to negative infinity. And then from the positive direction, it's going to go up, 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 all the way to positive infinity. So there is no value that this limit approaches. Well, it approaches positive infinity from this direction, negative infinity from that direction. It means there's no one limit to this. So for this, we say limit of 0 for 1 over x. We say limit does not exist. And D&E is just abbreviation for does not exist. You could write does not exist, or just think about it. We're probably not going to need this until later. Now let's find limits without graphing them. So as you saw in our previous method, what we did when it was a simple graph like a line or a parabola, we just substituted. We found the y value for the given x value. That means we substituted the x value into the function. So in something like number 1 here, limit as x approaches 2 for the function 3x, we know that it's going to approach the y value when x equals 2. So that just means that the limit will be the y value. We can say, we can just substitute 2 into the function, because that will give us the y value. So the answer for limit x approaches 2 of 3x is 3 times 2, which is 6. So we're going to say the primary way you're going to find a limit will be by substitute x into f of x. And remember that this is the function. That is f of x, and this is x right here. Right? So let's do a couple more like that. Given f of x equals 2x plus 5, find the limit as x approaches 0 of f of x. Well, we're just going to substitute. So substitute the x value in. X is 0 here. It's approaching 0. So 2 times 0 plus 5 is 5. So the answer for this limit x approaches 0 of f of x is 5. And then this is the same function, just with x approaches 4. The limit of x approaches 4 of f of x, we do the same thing. We substitute into x. So 2 times 4 plus 5 equals 8 plus 5, which is 13. So that answer is 13. But when using limits for derivatives, it will be a little bit more complicated. in that you'll often need to simplify the expression of f of x before you take the limit. So if we took the limit right now, if we just substituted, like how we have been doing up to now, we get 2 plus 1 times 2 minus 2 divided by 2 minus 2, which would simplify to 3 times 0, anything times 0 is 0, divided by 0. And 0 divided by 0 is what's called an indeterminate form. Indeterminate form. And all that means is that it's not an actual answer. This does not equal 0, because anything divided by infinity is infinity. Anything divided by 0 is infinity, and then 0 divided by anything is 0. So it's not really an answer. We don't know what that is. But there's a trick here. There's x minus 2 in both the numerator and the denominator of this function. So I can rewrite this. I can cancel the x minus 2's. Limit as x approaches 2 of x plus 1. Since those cancels, those aren't even there anymore. So then with this I can substitute. I can substitute 2 into the new f of x to get 2 plus 1 equals 3. So the limit as x approaches 2 of this function is 3. So I'm going to write here that the second method to solve the limit, if you can't use just substitution, would be cancel common factors in the numerator and the denominator. And that just means simplify. This means numerator, denominator, and I'm just going to say simplify before you substitute. So eventually you're pretty much going to always substitute. So we have a couple of more practice problems here. This first one, we are going to have to use both of these. So if you just substitute 4, you can try it. 4 times 4 minus 16 over 4 minus 4 equals 16 minus 16, which is 0, divided by 4 minus 4, which is 0. And that's an indeterminate form. So in math, what we write is we just write ind. You don't have to do that. That just means we're going to have to cancel something. So here it's not factored out already. We're going to have to factor it ourselves. So I'm going to write a new line, the limit as x approaches 4. And then this, the denominator, is already completely factored. But the numerator isn't. It looks like we can factor out a 4 there. So 4 times x minus 4 divided by x minus 4. That's the equivalent of the previous statement. And look at that, we can cancel the x minus 4's. So that means I can simplify this to the limit as x approaches 4 of 4. Well, no matter what our x value is, the function always equals 4. That means the y value is always going to equal 4. So that's a 4 there. I could have limit as x approaches negative 2 of 4, and that'd still be 4, because the y value is always 4. And then in this next problem, I just wrote an a instead of an x. Get used to using things besides a. Actually, later in this video, we will not be using x's for this value. So the limit as a approaches 0 of this, if you just try substituting 0, you get 0 plus 0 divided by 0, which is not a result. That's not an answer. Indeterminate form. So we can cancel common factors. It looks like there's an a in all of these, so I think I could cancel out an a from the numerator, or factor out an a from the numerator. There you go. And then cancel those to get the limit as a approaches 0 of a plus 3. And this is our simplified function, a plus 3. So by substituting 0 into this, we get 0 plus 3, which equals 3. So that means the answer to this is 3.